Good day learners, this is Mr. Botha. I will be responsible for today's lesson in natural sciences on parallel electrical circuits, more specifically on the effect of an increasing number of bulbs in parallel on the brightness of bulbs and on the overall resistance and current strength in parallel circuits. Before we go on, let's quickly revise what series and parallel circuits are. On the left, you'll see there's a series circuit. Why is this a series circuit? It's because the total current passes through all the components. Now, when you follow the current here, starting from the positive terminal of the battery, there in pink, you can see, and it's also indicated with arrows, the current is flowing through the switch, and the current is flowing and passing through both bulbs, total current, and it gets back to the battery over here. While the current is passing through the bulbs, we know there's energy conversion from electrical to light energy. Now, looking at the circuit on the right, this is a parallel circuit, and in a parallel circuit, the difference between parallel and series is that not all the current, or not the total current is not passing through all the components. There's a split somewhere in the circuit where the current is divided. And let us follow the current to find out where that happens. So the current again starts at the positive terminal. It flows through the electrical wires, through the switch here. Then when it comes here you can see there's like a crossroad. Now the current, some of the current or a portion of the current will move through the top branch, and the remainder of the current will move through the bottom branch. So just remember that if the resistance of the top branch, or then this top bulb, is the same as the resistance of the bulb here, then the total current will divide 50-50, meaning that if the current was 2 ampere, then 1 ampere will move through the top branch and 1 ampere will move through the bottom branch. And when the current rejoins over here, then the total current will be again the sum of the current that moved through the top branch plus the current that moved through the bottom branch, and then again total current, which is 2 ampere, will move through this wire back to the battery. Right, so learners, so now we will compare the difference between series and parallel circuits. When we compare the brightness of light bulbs, the overall resistance of the circuits, and also the current strength of the current that passes through the different components. Now what I have here is two similar series circuits. We can close both the switches, and at the moment we can see the brightness of the light bulbs are the same. I can introduce a special ammeter. This ammeter, you don't need to connect this ammeter in the circuit. It has this crosshair, which you can put anywhere on the circuit diagram, and it will show you the current strength at that point. So if you put it there, you'll see it gives a current strength of 1 ampere, meaning that 1 coulomb of charges is passing per second at the specific point where this target or the crosshair is put. So I can move the target up to there, it's still 1 ampere, even on the battery it's 1 ampere, 1 ampere, the current strength is 1 ampere everywhere. Even in the bulb itself, we can see these little blue circles, or the coulombs of charges, are passing through everywhere at exactly the same rate, which is at the moment 1 coulomb of charges per second, therefore 1 ampere. Putting it over here, we can see it's exactly the same everywhere where you put the target. The reading remains 1 ampere, so we've got exact same series circuits at the moment. Right. So now what I want to do now is, I'm going to introduce more circuit components, starting with bulbs. So I'm going to put in another bulb here. And the first thing you have to notice is that the brightness of the bulbs have decreased. When you compare them with the bulbs, or the bulb on the right side here, we can see we've got two bulbs in series now, and the brightness have decreased. Looking at the ammeter reading, we can see the ammeter reading has decreased to 0.5 ampere. So it is half the size, or it's 50% less than what it was before. Remember, before it was 1 ampere, now it's 0.5 ampere, so the current is traveling at a slower pace. And doesn't matter where you do your measurement, the ammeter reading is 0.5 ampere throughout the whole circuit. Even here in between the two bulbs, it's 0.5 ampere. And when you look at the current strength, the rate at which the current is moving, look at this little circuits or circles, and compare them with these little circles, how fast they are moving. It's a lot slower than these. So what I'm going to do is now I'm going to bring in another bulb here, and I'm going to connect this bulb in parallel to the first bulb. Right, just put that in there, and wow, see what happens, learners. The brightness is the same as before, so that the brightness didn't change when I introduced another bulb, which is very interesting, and we have to be able to explain this. Now let us look at the ammeter reading. The ammeter reading through this bulb is still 1 ampere. The ammeter reading through this bulb is 1 ampere. You can see that. And what is the ammeter reading there is 2 ampere. So the total current is double as big. It's 2 ampere until it gets to the branch. The branch is here, and at the branch you can see some of the current is going through this bulb and some of the current is going through that bulb. So this 2 ampere is now divided into 2, and it gives 1 ampere there, 1 ampere here. If you add the 2, you get the total current. So we could see that the moment we introduced another bulb, that number one, the total current increased, but the current that goes through the branches remained the same as before. And it's very important to note that. So to explain this, learners, it is almost like when you use a road where vehicles travel on, when there's a single lane for vehicles to move, then vehicles can't pass one another, and it's impossible for them to travel fast. The vehicles are basically limited by the speed of the fastest vehicle. If the fastest vehicle is not traveling fast, then all the other vehicles also have to travel at the same speed. But if you introduce another lane on the road, then vehicles can pass one another and the traffic can move faster. And it's the same thing that happened here. The moment we put in another bulb in parallel, the overall resistance of the circuit diagram decreased, and therefore the overall current, we could see the overall current is only here up to there, namely 2 ampere. It increased to 2 ampere. The overall current is also there. After the branch, it's 2 ampere. But through the branches itself, it remains 1 ampere, same as what the current strength was before we introduced another bulb in parallel. I'm quickly going to put in another bulb in parallel and see what happens. There's another bulb. Right, let us just put this in there. And right, here we can see the brightnesses are still the same. The total current is now 3 ampere, meaning that to have a bigger total current, the total overall resistance had to decrease, and that is what happened. The total overall current is bigger because the total overall resistance decreased, but the current through the 3 branches are still the same, namely 1 ampere. And this is a very, very important thing in electricity. And the application of this is when you connect the lights at your home. If you put in more light bulbs, the brightness of the light bulbs or the light bulbs that was already connected are not affected. And even the new ones that you connect in, the brightness is the same. It is not like in the series circuit that the more light bulbs you connect, that the lower the brightness or the dimmer it will become. The brightness remains the same. And why is it like this? It is because the more light bulbs you connect in parallel, the smaller the overall resistance will become, the bigger the total current will become, but very important, learners, the current through the individual light bulbs remain the same, irrespective of the number of light bulbs which you connect in parallel. So learners, now it is your time to answer the online quiz. You can do that by either scanning the QR code or by following the link. Good luck.